12.9 stationary point. Stationary point, we also call it turning point of a function y equal to fx occur when dy dx equal to 0. So we have the first derivative test that the dy dx equal to 0 for a maximum point or a minimum point. So at a maximum point, dy dx equal to 0, and then the gradient is positive to the left of the maximum and negative to the right. Minimum point dy dx equal to 0, the gradient is negative to the left and minimum and positive to the right. Okay, so second derivative test for maximum point and minimum point is we find the second derivative. If it is less than 0, then it is a maximum point, and it is greater than 0, then it is a minimum point. Okay, so we can have a example here. Okay, let's say we have y equal to uh, 2x squared. Okay, so the graph is look like this. Okay, so y is 2x squared. Then we have a minimum point. Okay, so we have y equal to 2x squared. Then we have a minimum point. So y equal to 2x squared. Then the graph look like this. It have a minimum point. So we can see that the dy dx is 4x. Second derivative is 4. Okay, so the dy dx equal to 0. That means the 4x equal to 0, x equal to 0. So when x equal to 0, it is minimum. Okay, so the second derivative when x equal to 0 is 4 greater than 0, so it is a minimum. So this 0, 0 is the minimum point. Okay, and we can see that it is the gradient is negative, and then gradient is positive, and gradient is 0. So negative, 0, positive combined, it is a minimum. Okay, let's say we have y equal to negative 2x squared. So y equal to negative 2x squared. So this one we have a negative here. Then the graph will look like this. So the graph is something like this. Then we have a maximum point. So dy dx is negative 4x. Second derivative is negative 4. So when dy dx equal to 0, then negative 4x equal to 0, x equal to 0. Okay, and the second derivative when x equal to 0 is negative 4, less than 0. It is a maximum point. So over here, this is maximum point. So the gradient is positive, 0, negative. So positive, 0, negative. Then the graph is like this. So it's a maximum point. So over here it say that the gradient is positive and then maximum and negative. So this is the maximum point. And if we have a negative minimum and like this, then this is a minimum point. Okay. Just now the example that I gave, these two example that I gave is quadratic. So the second derivative, they don't have x. And this one, the second derivative also, they don't have x. We'll look at this example. So the dy dx is 6x squared plus 12x minus 48. Then the second derivative is 12x plus 12. So if we want to have the dy dx equal to 0, then we have the 6x squared plus 12x minus 48 equal to 0. x squared plus 2x minus 8 equal to 0. And we do the factorization, we have the x 4 plus 4 minus 2. So we have the x equal to 2 and x equal to negative 4. Okay, so this one, the second derivative when x equal to 2 is 12 times 2 plus 2. So it is 36. And we have the negative 4. 12 times negative 4 plus 12 is negative 36. This greater than 0, so it is a minimum. This less than 0, it is a maximum. Okay. So for this one, when x equal to 2, y equal to 2 cubed plus 6 2 square minus 48 times 2 minus 10. Okay, then we will have the 2x power 3 plus 6x squared minus 48x minus 10. So when we substitute with 2, then we have negative 66. When x equal to negative 4, y is 2 times negative 4 cubed plus 6 times negative 4 squared minus 48 and negative 4 minus 10. Then this will be divided, substitute with negative 4, 150. So the 2 negative 66 is the minimum, and the negative 450 is the maximum. Okay, use decimals to plot the graph. We have the 2x power 3 plus 6x squared minus 48x minus 10. So the graph will look like this. Okay. Then we can see this this is the maximum and this is the minimum. 2 negative 66 and negative 450. So we have 2 negative 66 and negative 450. So this is the graph. And this is how the graph look like. Okay. So over here, if we say that it is maximum point or minimum point, actually it's not that true. Okay, I will say that it is a local maximum and a local minimum. Local minimum and a local maximum. Because it is maximum here, but later somewhere here have a value greater than it. And it is the minimum here, but over here have something smaller than it. So we will call it local maximum or local minimum. For this one, we will call this as stationary point. So because over here, dy dx equal to 0. Okay, so the gradient, that is the dy dx equal to 0 here. So we call it stationary point. So for this one also the same, the gradient, that is the dy dx equal to 0. So we call it stationary point. So stationary point, that is the dy dx equal to 0.